Our next speaker is Ece Ercan. She's going to tell us about the validation of inhomogeneous magnetization transfer imaging and preliminary results on multiple sclerosis. Her mentor is Elena Vinogradov.
Thank you for the introduction. So myelin is a membranous structure which is wrapped around the axons of neurons, and its main function is to facilitate the electrical transmission throughout the axons. And when we look at the structure of myelin, it consists of a phospholipid bilayer and with embedded proteins, and there is myelin water in between these phospholipid bilayers. And the lipid tails of phospholipid bilayer have dipolar couplings in between the hydrogen atoms. So as opposed to the normal nerve with intact myelin, in case of several diseases, including multiple sclerosis, the myelin is damaged. And this causes clinical and cognitive dysfunction in patients and physical disabilities. So it will be quite advantageous to be able to have a quantitative method which can show this damage and which can image the myelin. And this will really help with the early diagnosis as well as the treatment monitoring of diseases such as multiple sclerosis. However, it's not very easy to image myelin due to the very short T2 relaxation time of myelin. So by the time that we collect the data with the conventional MRI, we only get the signal from the tissue water, whereas the myelin signal completely decays. So therefore, alternative methods have been proposed throughout the years for myelin imaging. The oldest method for myelin imaging that was proposed in 1993 is myelin water imaging. And this method uses the T2 relaxation properties of myelin water, which is the water trapped in between the myelin phospholipid bilayers. So this is a multi-T2 type of method, and it attributes the short T2 components to the myelin water, and it can quantify the myelin with so-called myelin water fraction. So although it has been 25 years since the introduction of this method still hasn't made it to clinic due to several reasons. And the main limitation of the method is the very long acquisition time, as well as its model-based and complicated post-processing. Moreover, the information that we get with this method is not directly from myelin, but from the myelin water. Therefore, diffusion tensor imaging has been used widely in the clinical research studies of MS, because although this method is not really specific to myelin, it has been shown that radial diffusivity, which can be extracted from the diffusion tensor, is sensitive to reflect changes in demyelinated axons. However, this RD can also reflect changes due to inflammation as well as due to edema. Therefore, this is not a very good measure of myelin. So the current situation for myelin imaging is that the current methods are either specific to myelin, but they are not clinically feasible, or they are clinically feasible like DTI, but they are not specific to myelin. So therefore, a novel method is needed, which is clinically feasible and specific to myelin. For this purpose, inhomogeneous magnetization transfer imaging has been recently introduced in 2015, and this method is a novel enhanced magnetization transfer method which is specific to myelin. The signal that we can get with this method originates from the dipolar couplings in between the phospholipid bilayer of myelin, and it's quite easy to implement since this method is using a set of images and a linear combination of images with different single or dual of resonance frequency saturation. So the purpose of our study was to conduct a comprehensive evaluation of this very novel method in the human brain in vivo, and we wanted to validate this method through the comparisons with more established methods like myelin water imaging and DTI that I just talked about. And we wanted to also investigate the potential of this method to characterize disease-related changes due to multiple sclerosis. For this purpose, we acquired data on a 3D MRI scanner, and to validate ihMT, we acquired data from 8 healthy volunteers with a really narrow age range to exclude the age effect. And the data that we collected was myelin water imaging, diffusion tensor, and ihMT imaging data. And to evaluate ihMT in a demyelinating disease, we scanned 3 relapsing remitting MS patients with anatomical scans such as T1, T2, and T2 flare images, and we also collected ihMT images from them. To apply ihMT, we implemented and optimized the 3D steady-state ihMT pulse sequence, which is a preparation module, and which is followed by the acquisition of 1 line of case space. And this was repeated for each repetition time. In order to quantify the ihMT effect, we calculated the so-called ihMT ratio. And to be able to do that, we obtained 1 image with only positive off-resonance frequency saturation, and 1 image with only negative off-resonance frequency saturation, and 1 image with alternating positive and negative off-resonance frequency saturation, and 1 image with alternating negative and positive off-resonance frequency saturation. And by adding the single off-resonance frequency saturation images and subtracting the dual off-resonance frequency saturation images from them, and dividing this by a reference image, we calculated the so-called ihMT ratio. Here you see the ihMT ratio maps from the brain of one of the healthy volunteers, and you can already appreciate the very good contrast between gray and white matter with this method, which is in line with the myelin content in gray and white matter. Moreover, when we qualitatively compared ihMT ratio with myelin water fraction, we observed that the regions with highest ihMT ratios, such as internal capsule, corresponded to the regions with the highest myelin water fraction. However, we didn't see such a similarity between the DTI maps and the ihMT ratio. Furthermore, we quantitatively compared ihMT with myelin water imaging and DTI, and here in each circle you see the mean ihMT ratio that we calculated from the automatically segmented white matter regions of interest. And we have observed a very high correlation between ihMT ratio and myelin water fraction. And this was followed with a moderate correlation between ihMT ratio and radial diffusivity, and we observed weak to no correlation between ihMT ratio and the other DTI metrics. So our results confirm the myelin specificity of ihMT in the human brain in vivo. When we compared ihMT and anatomical images from MS patients, you can see that in the anatomical images, we can see MS lesions in terms of hyperintensities, and these are qualitative images. However, from these lesions, we can get quantitative results from the ihMT ratio maps. Moreover, from different MS lesions, we observe different levels of ihMT ratio. So this is also in line with the heterogeneity of the MS lesions. So this means that this method is promising to characterize the differences in different MS lesions. Then we quantitatively compared ihMT ratio values from MS lesions and from the normal appearing white matter from the MS patients, and we observed a significantly lower ihMT ratio from MS lesions compared to the normal appearing white matter. So the conclusions from our study is that ihMT is a very promising novel contrast method, and the images that can be obtained within clinically feasible scan times, and our results confirm the myelin specificity of the ihMT in the human brain. And the preliminary results that we obtained from MS are very promising. The future directions will include applying ihMT on a larger cohort of MS patients, as well as spinal cord applications. And I would like to thank you and thank all my collaborators and co-workers for their support in this study.
Are there any questions for Ece? There's one in the back.
Nice work. So what's the standard deviation or noise you're looking at in these images? And the other question is, what's the resolution? So can it be applied to peripheral nerves also?
So the resolution in the brain is 2.5 by 2.5 by 5 millimeter cube. And the standard, actually we looked at the coefficient of variation between all these methods. And it was lowest in DTI, but it was really highest in myelin water fraction. So it is acceptable about like 5% of coefficient of variation in this method.
So that doesn't bleed through in the signal itself?
Sorry?
that doesn't bleed into the signal itself. Like that's the problem with DTI when we do in the nerves. Like if you are looking at a FA value of going from 0.7 to 0.4 to be abnormal, the standard deviation itself is 0.2. So that's a big problem. So I don't know how it works for MS work, because if it's applicable in the peripheral nerves,
So
you can actually biopsy those nerves and then
Yeah,
get the ground truth.
Actually, right now we are trying to also apply this in the nerves, but so far we tried in brachial plexus, and because of the motion and because this is a subtraction-based method, we have a lot of problems due to we need to have better co-registration, but we will also try in the arm, in the peripheral nerves as well.
Yeah, sciatic nerve will be a good model if you want to try.
Are there any other questions? Neil.
So just thank you for that. Just wondering about any tests you've done for any tests you may have done for repeatability. So we see that beautiful image.
Yeah.
If we did the person 10 minutes apart, would you come up with the same or
So,
variable result?
Actually, we scanned the same person, and there was 1 month in between the two scans, and we got like an R-square of 90% or above. So it has good repeatability in that sense.
So I'm going to ask you to make a comment, I think, just to let people in the audience know. I think it's worth describing what you think the orientational dependence of this is.
So we also looked at the orientational dependence of this method, because dipolar couplings, they are known to be orientation dependent. So we looked at the DTI eigenvector, and then we extracted the angle of each voxel from the DTI. So we calculated the angle with respect to the main angle of the B0, and then we correlated this to the ihMT ratio, and we saw a very high correlation between the orientation and the orientation of the fibers and the ihMT ratio. So we think that this method is orientation dependent. So
Good.
yeah, we need to.
Thank you.